Hello again, my beloved students. So here we are in another video, in another lesson. So today we're going to talk about a topic that you are already familiar with it. And basically we will talk about chapter 8. The first section is probability. You might ask me, teacher, how about chapter 7? For now we just skipped our 7th chapter because we felt like chapter 8 is much more important than chapter 7. So for that reason, we just decided to go with chapter 8 before studying chapter 7. Anyway, well, in this section, in the very first section of this chapter, we are going to discuss about something that you already study, idea of it. You are familiar with it from grade 7, and in grade 8 you discuss about it. In grade 9 there was a specific chapter about it, which is probability. Well, let's just go to in the detail. In the beginning, there are some definitions that they are actually important to take care of them. They might come as a multiple choice in the quizzes, exams, and specifically final exam. So, as a suggestion, take care of them. They are in the book, and I just picked them and plot them in my PowerPoint in order to just have a short conversation about them. Okay. Random experiment. So an action where we cannot predetermine the outcome. For example, selecting a metal coin. For instance, a random experiment is when we randomly throw a coin. All right. We know the outcomes, but we cannot claim that which one 100% is going to come out. Okay. For instance, either head or tail. We cannot determine which one is going to come up 100%. We cannot predetermine it. That's why we call it random experiment. And the difference between random experiment and the experiment is when we do it one time randomly, so it is called a random experiment. But when we do it multiple times, when we throw a coin 10 times to see how many times we are going to get heads out of these 10 times and how many times we are going to get head and tail, in that case, when it is happening multiple times, so it's called experiment. As you can see, it is a random action or the repetition of a random action multiple times. For example, tossing a metal coin 5 times. When we just do it more than one time, so it's going to call experiment. Perfect. So the difference between random experiment and experiment is when we do the experiment randomly for one time, so that is called random experiment. Okay, any kind of experiment. And when we do it more than one time, so it will be repeated, then it is called experiment. Okay, how about sample space? So the set of all possible outcomes that can occur in a random action. For example, the sample space of a metal coin is just tail and head. For instance, let's just discuss about when the word probability comes to our minds in our books. So immediately we should think about coin, dice, and this kind of stuff. Okay, especially these two. While there are questions regarding to spinner, this kind of stuff. We have different types of questions. Well, when we talk about probability, particularly we need to think about coin and dice, okay? So in coin, how many outcomes do we have? We have tail and head, which means 2 outcomes, okay? But what about dice? So on a dice that it is in a cube shape, in a cube, how many faces do we have? We have 6 faces. So it means there are 6 numbers on it. Each face will represent a number. That's why our sample space in a dice consists of 6 possible outcomes. Okay? Therefore, the set of sample space in a dice is 6. In a coin, it is 2. Okay. So the set of all possible outcomes is called sample space. How about event? A possible outcome or set of possible outcomes, for example, getting head when tossing a metal. So each outcome is called an event. For example, getting a head when we toss a coin, or getting a head So each one of these outcome is called an event, okay? Or getting number 1, number 2, or each number on a dice is called an event, all right? Because here it's a possible outcome or a set of possible outcomes. For example, getting the heads when tossing a metal coin. So getting selecting each outcome is called an event. How about probability, which is the most important definition here? So probability, a measure for the occurrence of an event. When we say that an event is like the probability, the chance to happen something, an event to happen is, for instance, 50%. So that measurement is called probability. Okay? And the thing that it is important here, and you need to take care of it, is its value is between 0 and 1. Yani probability cannot be a negative number, and it is impossible to be greater than 1. Okay? So there are 2 points that you need to remember about probability. The measure of probability cannot be negative. We cannot say that the probability of, for example, happening that event A, is negative 50%. That doesn't make sense, okay? That is meaningless. As well as we cannot say the probability of happening an event is more than 1. For example, the probability of something that happened, it's like 2.5. That is impossible. That's why probability in terms of decimal number, it is between 0 and 1. Because probability can be expressed in different ways, in terms of percentage, in terms of like fraction, in terms of decimal. These are the ways that, in terms of words, like for example, remember impossible. There is something here, when the probability equals 0, it's called an impossible event. However, when the probability equals 1, it's called a certain event. So remember, when it was between 0 and 50, it was called like unlikely. When it is 50%, as likely as not. When it is between 50 and 100, likely. And when it is 100%, so it is called certain case. Okay, that is all about probability. And there is a formula, experimental probability says that probability of an event A, let's say, it is the number of times that the event occurred. So that event that we are just discussing about its probability, how many times it occurred, it happened, over the number of times the experiment was conducted. And the number of the times that the event will happen over the number of the times that the experiment is conducted. Okay, for instance, when we toss, like when we are tossing like a coin for 20 times, and our event is to getting head. If we get 11 times ahead, if the coin lands on head face for 11 times, so what will be the probability of head? Of course, the probability of the event which occurred is like the number of the heads, which is 11, over the number of the times that the experiment is conducted, which is 20. So 11 over 20. Okay, there are some interesting examples here that we need to discuss about each and all of them. What is the probability of a person being affected with the virus? If you know that the spread of that virus is 13 people out of 100,000. So we will say that, okay, probability of the person, okay, it equals to the number of the event that occurred. So it says 13 people are like infected to this virus. So 13 out of how many people? Out of 100,000. Okay. So till like we can just write it as as a fraction in a fraction form, or you can just turn it to a decimal form, which is 0.0013. Okay, or you can write it in a scientific form, scientific notation form, which is 1.3 times 10 powered by negative 4. See, look, 1, 2, 3, 4. So it's going to come here, 1.3 times 10 powered by negative 4. You study this one from like since grade 7. I think in 6 as well you study it. Okay, scientific notation, how to write numbers in scientific notation. Anyway, just the fraction form is enough. Normally, either it's in this form or in the decimal form, okay? Next question is similar question to this one, just the number are changed. What is the probability of a person being affected with the virus? F. You know that the spread of that virus is 19 people out of 50,000 people. So 19, okay, so in that case, it would be probability of that person would be, sorry, I think just, here. Okay, so how many people are infected? 19. So 19 over 50,000. That is the probability of a person being affected with this virus, according to this information that it is given in the question. Okay. The next example is saying that Danas threw like a dice. What is the probability of getting an odd number? These are like some familiar questions that we already got familiar with them in 9th grade. So, probability of getting an odd, so probability of odd number on a dice. On a dice, totally how many outcomes do we have? We have got 6 outcomes. Out of these 6 outcomes, you know, number 1, number 2, number 3, 4, 5, and 6. How many of them are odd? So number 1, number 3, and number 4. I hope that you know what are the odd and even numbers. So 3 over 6. And if you just simplify it, so it equals to 1 over 2. So half of these 6 numbers are odd numbers. The second one is, what is the probability of getting a prime number when he throws the dice again? So again, probability of prime is, how many outcomes do we have? We have got 6 outcomes. Okay, out of these 6 outcomes, how many of them are like prime numbers? So number 2 is the starting prime number, by the way, in the set of prime numbers. I hope that you know that. Number 3 is also prime number. Number 5 is also prime number. You might ask me, teacher, what is prime number? So prime number is a number that it has got only 2 factors. They are divisible on only 2 numbers, 1 and themselves. That's it. So 2, 3, and 5. And by the way, 1 is not a prime number, plus. So in that case, it would be 3 out of 6, which is again 1 over 2. You can write 0.5 as well. Both of them are the same thing. Okay. So here is like fundamental counting principle. If one event can occur in m ways and another independent event can occur in n ways. So when we have 2 events and they happen at the same time, they occur like at the same time, but in different ways, then the 2 events can occur together in n times m ways. Like for example, when we toss like a coin and throw a dice, in how many ways they can occur together. So coin can occur in 2 ways, either heads or tail. That is 2 ways. Dice as well can happen, like can land on 6 different faces, so 6 possible outcomes. 6 times 2, 12. Yani, if we just toss a coin and throw a dice, these 2 can occur together in 12 different ways. You can just try it at home. Okay, for breakfast at a hotel, there are 2 types of drinks, tea and coffee, and 3 types of food, cheese, yogurt, and eggs. We can only choose 1 type of food and 1 drink. In how many ways we can choose a food item with a drink? So first of all, how many drinks do we have? 2. How many foods do we have? 3. So 2 times 3, 6. So we have got 6 ways to choose an item of a food with a drink, and at the end it says that illustrate with a diagram. So the diagram is like this. The item is, how many drinks do we have? We have got tea and we have got coffee. So with our tea we can have 3 choices. Okay, either we can have cheese, or instead of cheese, we can have yogurt, and we can have egg. Or instead of that, instead of tea, we can have coffee with these 3 choices. So I can choose coffee with like cheese. I can have coffee with yogurt, I can have like coffee with egg. Coffee with egg doesn't make sense. Okay, these are the 6 choices that I have. 1, 2, 3, 4, 5, 6. 6 choices that I can choose. I can pick any of them. Okay, perfect. Let's move to the next example. Okay, for breakfast at a hotel, there are 3 types of beverages. So tea, beverage, like it's just like drinks. So tea, coffee, and juice. I just use the word of sharbat. And 3 types of food: cheese, cream, and eggs. In how many ways we can choose a food item with a drink, illustrated with a diagram. So again, let's just see how many choices do we have before just showing it in a diagram. 3 drinks, 3 foods. So 3 times 3, we can have like 9 ways to choose an item that includes a food with a drink. Okay, so we can say that our item is something like this. It can be tea. It can be coffee, and it can be sherbet, which is juice. Okay, juice. With tea, we have 3 choices. We can have cheese or cream or egg. As well as with coffee, we can have each one of them. So cheese, cream, and egg. With sherbet, we can have cheese, cream, or egg. So totally, how many choices do we have? Of course, we are going to count the end part of the trees of the diagram that we made. So 1, 2, 3, 4, 5, 6, 7, 8, 9, and that's it. So 9 choices. 9 ways that we can pick any of them for our breakfast. Okay. And then there is an interesting example in your, like among your exercises that it is familiar, like from the previous year we studied. If a die is rolled once, what is the probability of the throwing of the following events? So the probability of getting an even number. So in a dice, how many faces do we have? How many like outcomes do we have? 6. Okay, so we are going to say that probability okay, I think it's white. Okay, probability of even number. Out of 6 numbers, 3 of them are even numbers. So 1 over 2. You might ask me which one. So number 2, number 4, number 6. 3 numbers of them. 3. The probability of getting the number 3, so the probability, not only 3, the probability of getting each number is 1 over 6. Okay? The probability of getting a number less than 4. So how many numbers are less than 4 over there? Number 3, number 2, number 1. So basically 3 over 6, which is 1 over 2. The probability of getting a number less than 7, all of them are less than 7. So it's a certain case, 1. 6 out of 6. The probability of getting a number greater than 6, impossible. None of them are like greater than 6. So 0. 0 over 6, which is 0. The probability of getting a number less than or equal to 5. Less than or equal to 5. So 5 itself, 4, 3, 2, 1. So basically 5 over 6. The probability of getting at least 1 even number. So since we just rule it like 1 times. So again, it's going to be the same with the first one. To get an even number, we have 3 possibilities out of 6 possible outcomes. So it's just 1 over 2. When they are going to be different, when they are going to make different results, like part A and part 7, if the dice ruled more than 1 times. Okay, so then the situation would be different. And there is another example, an interesting example that I love it personally a lot. Ara was playing a game of dart throwing. He created a target with 3 concentric circles. They have got the same center. And threw darts at it. what is the probability that the dart hits one of these areas? Basically, this is not a multiple choice question. First of all, it talks about area. Okay? So, we need to get the total area. Yani imagine this is the board of the game. That is the game board. Its area, you know, it is in circle, like it's a circle. The area of circle, we use pi r square. Pi r square. So the radius, r stand for radius, pi, just keep it, times the radius of the board is 3. At the same time, remember that 3 is the radius of the green circle. Perfect. So 3 powered by 2 it equals to 9 pi. That is the area of the board. Okay? Great. So remember, if you want to get the probability of hitting each area of this color, denominator of each one of these cases is equal to 9 pi. Be careful, because this is the total area, like the area of the board. 9 pi. But now the question is, what is the area of the green one? The green circle. So imagine if you want to get the green area, we need to take out this one. This part, which is the red circle. So it includes the yellow one as well. So how are we going to do it? We said that the area of the green one is exactly the same with the area of the board one, which is look, it has the same radius. That's why it's 9 pi. But the problem here is that part is not green, so we need to take it out. How are we going to take it out? First of all, we need to calculate the area of this part. So of this part, this circle, the blue one. What is its radius? It's 2. So area of that part is pi times r2. So its r is 2. 2 powered by 2, 4. So it's equal to 4 pi. Now, the total area is 9 pi. Take out this from it, which is 4 pi. So 9 pi minus 4 pi, it equals to 5 pi. So we can conclude that the area of the green circle is equal to 9 pi. 5 pi. Pi is going to cancel with this pi. What will remain? 5 out of 9. Okay, that is the area, the probability of the dart that hits the green area. How about the red one? If you want to get the area of the red one, of course we will face the same situation. We need to take out the yellow part. Okay, in order to take out the yellow part, calculate, we already know that the area of the red one is 4 pi. How we calculate it here. So what about the area of the yellow one? The area of this yellow circle. Its radius is what? 1. So pi times r squared. Its r is 1. 1 squared, it's 1. So 1 times pi, it's exactly pi itself. 4 pi minus 1 pi, it equals to 3 pi. So it means that the area that will be remaining for red part, it's just like 3 pi. So 3 pi over 9 pi. If you just simplify, pi goes with pi. 3 over 9, it equals to 1 over 3, if you simplify. And finally, the area, the probability of the dart that hits the yellow area, it's simply the area of the yellow circle. Well, its radius is 1. We already calculated. 1 times 1 squared, it's 1. 1 times pi, 1 pi. So pi over 9 pi. Basically, this pi would go with this one. And what will remain? 1 over 9. So the probability of hitting the green part is 5 over 9. The probability of hitting the red part is 3 over 9, and the probability of the yellow one is 1 over 9. That is how to deal with probability. I hope that you go and solve all the exercises that left, and we couldn't solve it because of the time. I don't want to make it longer. That's all about probability in grade 10's book, first section. Well, I hope that we see each other in the other videos, in the other lessons of probability. Take care of yourself. Bye-bye.